Today we're going to do the modified Atwood's machine problem. The modified Atwood's machine problem has a block sitting on a frictionless surface attached to a string that's over a pulley. There's no friction for the pulley to spin, but there's enough friction to keep the string tight on the pulley. The first thing you want to do is draw two force diagrams, one for the block on the table and then the one for the hanging block. The block on the table, the blue block, we'll call that M1. The forces on M1 are its weight, which we call M1G, and then the normal force between the block and the table. And because the acceleration is 0, those two forces balance. And then there's the force from the string, which we'll call T for tension, pulling it to the right. The next force diagram we're going to draw is the one for the hanging weight, the little green one. That one is, its weight is M2G. And then the force on it is also the tension. Now, because these two tensions are the same string, those are equal in the force diagram. As we can see, the blue block, the unbalanced force is to the right, so it's going to accelerate to the right. And for the hanging green block, the unbalanced force is down, the weight is bigger than the tension, therefore it accelerates down. To find the acceleration, I want to use a Newton's second law statement for the system. So I'm going to say that the acceleration of the system is equal to the net unbalanced force on the system over the mass of the system. Now what I like about this is, in order to figure out what the net unbalanced force is on the whole system, we have to examine the force diagram. This normal balances out this weight, this tension balances out this tension, because one is upward toward the pulley, the other is sideways toward the pulley, and those balance within the system concept, and therefore the unbalanced force on the system is the M2G. So we say the acceleration of the system is equal to M2G over the mass of the system is M2 plus M1. And then if you were given values, you can plug and chug and get the acceleration of the system. Once you get the acceleration of the system, you can then solve for the tension in the string. And you can do this with either block. So let's do the green one first. The acceleration of the green block, M2, is equal to the net force on block 2 over the mass of block 2. And in order to get the net force, it's going to be the unbalanced force given by the force diagram. The acceleration of block 2 is equal to M2G minus T all over M2. The acceleration of the system is equal to the acceleration of block 2. That's why we do big minus small, is to keep it all positive. And if you knew the acceleration, you could plug and chug and get the tension. You could also find the tension if you use the mass 1, the one that's on the table, because the acceleration of block 1 should be equal to the net force on block 1 over the mass of block 1. The acceleration of block 1 therefore would be equal to, and then when we go to figure out what the net force is, if we look at the force diagram, we can see since the normal balances the weight, the unbalanced force is just the tension over M1. And so from here, if we plugged and chugged and got the acceleration of the system, we know it's equal to the acceleration of block 1. You can just plug it in and solve for the tension. And if you do this correctly, this tension here should match this tension here, and that's how you know you've done it correct.